is going to be a pretty quick lesson because we've already dealt with histograms and box and whisker plots. And so now we're analyzing these, and we're just going to be talking about the shapes of distribution of them. And so we're going to be talking about the shapes of each of these different graphs, and your homework will be Big Ideas 10.3. Okay, so as you can see, when I look up here at my histograms, the one on the left, so that shape of a histogram, that means it's skewed left. And that says the tail of the graph extends to the left, which means most data is on the right. So if you look up here, most of the data is over in this area, okay? And the tail goes down. It's sloping down right there. And so that's skewed left, okay? So that's sloping left, like you're going down the stairs to the left, okay? The one in the middle, this one is the easiest one to determine, and it's just symmetric. Okay, it has about the same amount of data on the right side as it does on the left side. It can be a little bit off, but for the most part, if you cut it down the middle, the right side would be the same as the left side. That's what symmetric means. Okay, so it says the left side of the graph is a mirror image of the right side of the graph. So like I said, the right side is the same as the left side, or pretty dang close. So then this last one is skewed right, and that's just the opposite of being skewed left. Okay, it means the tail of the graph extends to the right, so it's sloping down to the right, so sloping right. And it means most data is on the left over here, and it's sloping down to the right like a slide. Okay, so those are the difference between those three. So we have skewed left, and it's sliding down on the left. We have symmetric, which is about the same on the right and the left, and then skewed right means it's sloping down to the right, and most of the data is on the left. Okay, so you're just going to be figuring out, you're going to be analyzing these different graphs and trying to figure out if it's symmetric, if it's skewed left, or if it's skewed right. Okay. This is another example with the box and whisker plots. So the data for skewed left, so all the data is bunched up on the right, and it has a long tail on the left. So this is skewed left. Okay, it basically means that the left whisker is longer than the right whisker. Okay, so these ones are easier to determine, okay, because it's just about the whisker lengths. So this is symmetric because the left whisker and the right whisker are about the same length, okay, and the median is in the middle of the box. Okay, so this one, if you cut it right down the middle of the median, the left and the right side would look exactly the same. That's what symmetric is. Whereas this one, skewed right, the right whisker is longer than the left whisker, which makes it skewed right, which means most of the data is on the left side. Okay, so we have a few examples of some histograms and some dot plots. Okay. So this first one, you gotta think, so if you cut it down the middle, it's very similar on the right and the left. So even though like this one's at 5 and this one is probably at 4, they are still very, very similar. And so this one would be symmetric. I don't think I spelled that right. Yes, I did. Okay, so first one's symmetric. The second one, we had to figure out, so I kind of think to myself, where's the slide at? Okay, this one would be a really fun slide, but a little dangerous, okay? Whereas this one kind of slopes down like a normal slide. So this one is skewed left because it's sloping to the left and most of the data is on the right. Okay, so it's skewed left because of that sliding down the left side. Okay. So this last one on this example, you can see, so there's a lot of data right here on the left side, and then it slopes down the right side, so it's skewed right. Okay. And these basically just tell us that the more you go to the right, the less data there is from the middle, and on the left side, there's more when it's skewed right. Okay. So those are some examples. On this next one, we're going to be creating a histogram and then describing the shape. Okay. We did this a few classes ago, so hopefully you remember. Okay. So we have our ages and we have our frequency. Okay. frequency is always going to go on the left. So you do, I'm going to abbreviate frequency. And on the bottom, we have ages. Okay. Our frequency on the right side, it needs to go up. Our biggest number is 20. So we need to have 1 through 20 over here, or 0 through 20. So I'm going to start at 0. I'm going to count up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have our 20. And then on the bottom, we have the ages. And they're already in order for us. So we're going to start with 10 to 13. So 10 to 13. 14 to 17. 18 to 21. 22 to 25. 26 to 29. 30 to 33, and then 34 to 37. Okay, try to make it look as nice as you can. Some of mine are really close together and it's hard to tell what's what. But once we add our bars, it should make it a little easier. Okay. So for ages 10 to 13, there was one person that was between those ages. So we would do 1, I'm going to do a different color. We'll do 1, like right there. Okay. Ages 14 to 17, we have 3. So it's going to go up a little bit more. Then 18 to 21, we have 7. It's going to go up even farther. So you should be able to start to tell kind of what, if you think it's going to be skewed left or skewed right, or if it's going to be symmetric. So 22 to 25, we have 12. Then we have 26 to 29, and we have 20 of them. Okay, see, mine's getting a little off. We're going to move some of these a little bit. Okay. Let me redo this real quick. 26 to 29. That's going to be 22 to 25. 30 to 33, and then 34 to 37. So we just won't use the whole graph. All right, 30 to 33, we have 18. And then last, 34 to 37, we have 3. Okay, just like that. So I want you to think about the slide. Okay, is it this way or is it this way? Okay. It should be skewed to the left because most of the data is on the right and we're sloping down on the left side. So this would be skewed left. Just write that somewhere on your paper. All right. Okay, a few more questions. So this says, the histogram on the left shows the ages of people watching an animated movie, while the histogram on the right shows the ages of people watching a comedy. Which movie has an older audience? So the one on the left is animated. The one on the right is a comedy. So we're trying to figure out which movie has an older audience. So that means which movie has more older people coming to watch. Okay? So you can see on the animated movie, most of the data is on the left side. So that's 10 to 13-year-olds, 14 to 17-year-olds, 18 to 21-year-olds. Okay? Whereas the comedy movies on the right side, most of the data is on the right. So that means most of the people coming to watch the comedy movie are 22 to 25, 26 to 29, 30 to 33, and 34 to 37. Okay? So the comedy movies have more of an older audience than the animated movies. So we would write comedy. Okay. All right. Last questions. The double box and whisker plot represents the prices of snowboards at 2 stores. Okay, so this first one, store A, second one is store B, and it's all the prices of snowboards at both stores. So the first question is, describe the shape of store A's distribution. So if we're looking at this right here, what do we think it is? Is it left skewed, symmetric, or right skewed? So when we have box and whisker plots, it's about the whisker lengths. So we have this one, and there's the median. So store A is symmetric, because if you cut it down the middle, the left side is pretty much the same as the right side. Okay, the whiskers are about the same length, so that's symmetric. Next question says, describe the shape of store B's distribution. Okay. So we have this one right here, and we have this whisker length, and then the median. Okay. Remember, when we have box and whisker plots, it's all about which whisker is the longest, and the right one is the longest, so it is right skewed. Or it's skewed right. Okay. The last question is asking which store's prices are more spread out. So if you think back to our mean, median, mode, and range, one of those tells us how spread out the data is by showing us the greatest from the smallest. And that's range. So store A, our greatest is 450. And our smallest is 150. So I have A, we're going to do 450 minus 150, which equals 300. And then we have store B, which is 650 minus 250. So 650 minus 250, which equals 400. So that means store B's prices are more spread out because they have a $400 difference from the lowest price to the biggest price. All right.